We all set? Can you get my screen right now? Well, I don't know. Hold on. So are we broadcasting okay there, Miss Kalai? I hope so. I got a good crew here. All right, so we're good here. So I'm at my dashboard as an instructor for the code.org, and I'm going to show you a little bit about what we can do. We're going to do an activity here, and as I share my screen here, you can see that some of the activities that we have go all the way from some second graders, sixth graders, all kinds of things like that. And I thought just for right now, we go into the third grade course. All right. So some of you are going to find this real easy. Maybe some of you already done it before. But a lot of the activities that we have here are something you can do at home. Matter of fact, every one of you can do at home. And we're going to get started with a little bit of practice here so we can see what's happening with our coding. All right, here we go. So this is, I think probably some of you are familiar with this. This is a little practice, introduction to online puzzles. You can read along here after connecting all the blocks, press run to start your program. All right. Let's watch a little video here and see if that'll give you some more information.
Today, we're going to learn to program using a drag and drop language called Blockly. Blockly uses colorful instructions called blocks to build programs that you can use to solve puzzles. Under the hood, you're still creating code. Each puzzle you'll solve with the code is split into 4 main parts. On the left is the play area where your program will run. In the center, you will see the toolbox area that holds all the blocks that you need for each puzzle. To the right is your workspace, where you will drag blocks to build your program. Finally, above the workspace, you will see the specific instructions for each puzzle. Don't worry if you accidentally drag out a block that you don't need. If you have an extra block, simply drag it back into the toolbox, put it away. After you hit run, you can always hit the reset button to get your character back to the start so you can try again.
So one of the things I like about this program is they have different videos that tell you what you're going to be working on. As I said, this is about a third grade level. Some of you are older than that. Maybe some of you are younger than that, but it gets a good place to start. So we'll see what we can do here and do some of these programs here. So for this puzzle, snap all the blocks together and click run. So as we know, Flappy Bird is after the green pig. So I bet you if I was asking my students, I'd say, well, what do we need to do? We need to move forward twice. Then we're going to put those Blockly language blocks in place, and then we'll run this program. All right. So I just wrote 2 lines of code. It was easy. It was easy to understand, and we'll just continue for a while here. Now, if you were in my classroom with my students, I would let them work, and I would help them if they needed work. So let's see what we can do here. I might even ask some of the students that are on right now, what do you think we ought to do next? And then some of the students might tell me, oh, Mr. Moe, we need to go forward 3 times. I say, all right, 1, 2, and then I might have to go get another one and move it over here. 3 moves forward. Let's run it and see if I got that right. All right, we're doing well. It gives you good feedback. For those that ever teach, you know you need instant feedback to do good learning. All right, so on this one here, it says help the bird get to the pig. There's one extra block, so we're gonna have to throw one away. So we gotta go forward, and then we're gonna have to turn left. So I think I've got one that's too many. So I'm gonna have to manipulate the Blockly code and throw that one out. See, I don't want that one. So we're gonna move forward. Then, whoa, what did I do? I gotta put my turn left in a different place. So I'm gonna throw this one out. As I said, you can do this at home. It's easily done. Like that. Let's see if that'll work. Yeah, let's try it. Move forward, turn left, move forward, move forward. As easy as that. Now, for some of you that are thinking, oh man, you just keep doing the same thing. It does start talking about loops, the ability to repeat, and that's when you start really thinking through your code and how to apply that. So once again, if I was in there, it says, lead me to the pig. I'm gonna have to move forward. Then I'm gonna turn right. Then I'm gonna move forward. Then I'll have to turn left and move forward. And if you make a mistake, it's not any problem in the world. You can reset this puzzle. Also, you can see if you're coding correctly by looking over here at your workspace. It says it should take 6 blocks, and I'm using 6 blocks. So let's see if this works. Yeah, so far so good. So far so good. All right. All right, so we're doing all right. This is not too difficult, as I said, but it gives you an idea. For example, right here, I can use 6 blocks. So I'm gonna go move forward. All right, move forward. Some of you can go onto your computers. As I said, you do this from home, and it shouldn't be too hard at all. And as I said, there's some harder ones and some easier ones to do. And let me see if I get this one right. There's 6 blocks. Let's run it. All right. So we're going through it pretty quick, but as I said, I'm a little older than a 3rd grader. But now here's a little bit, here's a loop or repeat block. And let's see if we can do that. I can use up to 10 blocks on this. So let me see. I might use a move forward. How many times? 1, 2, 3, 4. I might put a 4 right here instead of a 5. Let me see if that'll work. All right, then I'm going to turn right. And then I'm going to move forward again. And I think I'll move forward. 1, 2, 4 again. So let's see if I did that. Now I can use up to 10 blocks, but I only use 6. All right, let's see if this works. 1, 2, 3, 4. Turn right. 1, 2, 3, 4. So that's when we start using a loop or a repeat block. But anyway, those are some things that we can do here. Here comes the challenge puzzle. So it'll give you a challenge every once in a while. And it says, you got to stretch your brain. So Lucas, I hope you're stretching your brain right now so you can learn how to do this. All right. Look how far we got to go here. Navigate the maze. I can use up to 16 blocks, but I think I can do it in less than that. So I could go to a move forward. Then I could turn left. You see 1, 2, then I can move. I might be able to do this. Put a 2 in there. All right, move forward. And then if I said, well, I don't know if I got that quite right, I can stop right here and run it. Yeah, that looks right. 1, 2. All right. So I'm not finished, but I was able to check the steps of my code. And I encourage kids to do that from time to time when they have a lot of code to write. They can do half steps and check them. All right, so I'm going to have to turn right now. All right, then I'm going to repeat, block. I think I'm going to go 1, 2, 3 right here. All right. Ooh, hold on. I have to move forward. Then I'm going to turn left. Then I could use my repeat block again. Move forward just 2 times. Let's see if this will work. So I use my repeats. Yeah. 1, 2. 1, 2, 3. Turn left. 1, 2. All right. All right. So I've written 10 lines of code on that one. But we can do more things. You know, I think it's fun to look at other programs. One thing I like about code.org is if you look at some of the other things they have here, let me log out real quick. I'll have to log out of my teacher page if I can get to it. Okay. Here we go. I can sign out. So I can go back in. We can do some other things in code.org. All right. Now, as I told you, there's a lot of programs to do. And I like this. I told you you can learn at home. Every year they have an hour of code program. All right. So there's lots of things to do. And it says over 89 million code.org projects are created. That means there's lots of things you can do. All right. If I do an hour of code, that's something you can do at home. There's Dance Party. There's a Minecraft app right there. You can do that. We did some Flappy Birds, Angry Birds. We just finished doing Classic Maze. So there's all kinds of activities to do in here that are a lot of fun. So I think I'd like to show you one that I like a lot with some of my kids. You can make your own game. Let me see. As I said, at home, on your own, feel free. There's all kinds of programs to do in here. Some of you will recognize some of them. You can see them, and anyone that you like to do. Here's one a few years ago. Frozen was real fun for a lot of kids. I did that one a lot with my kids. Here's a Star Wars one. So you can start Star Wars. All right. For those that want to use JavaScript, you can do that.
Hi, I'm Kathleen Kennedy, and I'm the producer of Star Wars: The Force Awakens. Today, you'll be working with one of our stars, BB-8. BB-8 is a spherical droid. Everything he does and every movement he makes is controlled by computer software. Computer science impacts every industry, from marketing to healthcare to film. In fact, hundreds of computer engineers work together to make a film like The Force Awakens.
Hi, I'm Rachel Rose. I'm a senior R&D engineer at ILM, and I lead the animation and creature development team. In The Force Awakens, I'm responsible for helping the artists develop rigs, which are the parts of the character that move, that allow the character to look very believable in a galaxy far, far away. In the next hour, we're going to build our own Star Wars game that will teach you the basic concepts of programming. Usually programming is all text, but we're going to use blocks here so that we can drag and drop to write the programs. To start off, we're going to work with Ray to program BB-8 to walk to collect all of the scrap parts. Your screen is split into 3 parts. On the left is the Star Wars game space, where code will run. The instructions for each level are written below the game space. This middle area is the toolbox, and each of these blocks is a command that BB-8 can understand. The white space on the right is called the workspace, and this is where we're going to build our program. If I drag the move left block to our workspace and press run, what happens? BB-8 moves left 1 block on the grid. And what if I want BB-8 to do something after the move left block? I can add another block to our program. I'm going to choose the move up block, and I'll drag it underneath my move left block until the highlight appears, and then I'll drop it, and the 2 blocks will snap together. When I press run again, BB-8 will perform the commands that are stacked from top to bottom on our workspace. If you ever want to delete a block, just remove it from the stack and drag it back into the toolbox. After you hit run, you can always hit the reset button to get back to the start. Now, let's get rolling.
All right. So we'll see if we can do an activity together. All right. We need to pick that scrap metal up. Let's see what we can do. All right. So BB-8 needs to move forward. Move right? I don't know. Let's go move right. I think he's got to move right twice. Let's see if this will work. Got it. All right. Once again, this is not a difficult code to do. We can continue. So if you do this at your home, you can be going along at the same time, just like I did. As I said, it's free. You just log on to code.org, and there's hundreds of activities. All right, so BB-8 needs to go get a couple more pieces of this scrap metal. Move right. I think he's going to have to move right again. He's going to have to move down a couple times. Let's see how he does here. All right, let's start. All right. Nothing too difficult, but as you go, you'll find out it gets more and more challenging. Okay, so far, nothing too difficult. I don't think this is difficult anyway. All right. So, wow, let me see. I think he's going to have to move down, move left, move left, move down, move down, move left. Let's see if this one works. As I said, if you get it wrong, it's okay. All right, so far so good. All right, so that's one program. We can do other ones. They get more and more difficult, challenging, but there's other programs. Let me see if I can find, here we go. We'll go back to the studio. And we can start doing, here's let me see, let's do a little bit of this, so we can do some Minecraft. Let me see. I don't know, I've done some of these.
My name is Jens Bergensten, but I'm better known as Jeff. I'm the lead developer of Minecraft here at Mojang in Stockholm. I think I was 11 or maybe 12, and I started programming because I wanted to make games, and one of my father's friends told me that in order to make games, you need to learn how to program. So that's how I got started. I like designing and figuring out the architecture of things. That's what I really like about Minecraft. Over the next hour, you're going to learn the basics of computer science by programming Alex or Steve to move through a simulated piece of a Minecraft world. Traditional programming is usually in text, but today we'll use Blockly, a system which uses visual blocks that you can drag and drop to write programs. Under the hood, you're creating JavaScript code. The concepts that you'll be learning are what computer programmers use every day and are the foundation to computer science. Here at Mojang, we use these same concepts to make Minecraft work. Before you start, you'll pick your character. I'm going to choose Alex. Let's build code for a program that will help her move around the screen. Your screen is split into three main parts. On the left is the Minecraft play space, where your program will run. The instructions for each level are written below. This middle area is the toolbox, and each of these blocks is a command that directs Alex's actions. The white space on the right is called the workspace, and this is where we'll build our program. If we drag the move forward block to our workspace and then click run, what happens? Alex moves forward one space on the grid. And what if we wanted to do something after she moves forward one space? We can add another block to our program. I'm going to choose the turn right block, and I'll drag it underneath my move block until this orange line appears. Then I'll drop it, and the two blocks will snap together. When we press run again, Alex will perform the commands that are stacked from top to bottom in our workspace. And if you ever want to delete a block, just drag it from the stack back to the toolbox. To undo your changes and get back to how the level started, use the Start Over button in the top right corner of the workspace. One more thing. You see the little triangle on the turn blocks? Anytime you see these triangles, it means that you can pick a different option. Let's start coding.
All right. So let me see, add a second block to reach the sheet. Now, if I was in my classroom, I would say what to do. I'd say move forward. All right, let's see if this will work. Hey, it worked, we did okay. All right, this is very much the same as we have been doing using Blockly language. All right, let's go to our next task. All right, wood is very important. Many things are made for it. Walk to the tree and use the destroy block to chop it down. All right, I might move forward. Then I'll use my, I didn't get that clicked in. Then I'll use my destroy block. Let's see if Alex does this okay. Looks like we're doing okay. I don't think this is too difficult. All right. We'll do a couple of these. I'm just showing you different programs that you can do from your home. All right. As I say, it's free of charge. Sheep shearing time. Use the sheep command to gather wool, or the shear, excuse me. So I'm going to move forward. Then I'm going to shear. Then I'm going to turn right and move forward. And then I'm going to shear. Let me see if this will work. Oh, I messed up. All right, so I'm gonna have to put another move forward in here. Looks like. Now we'll try it. So I reset, run it again. All right, so you can see how that works. Not a problem at all. And you can keep going with this activity. So we've showed you Star Wars, we've showed you Minecraft, we've showed you Angry Birds. Let's see what else is out there. There's one that works on your geometry skills for those that are learning angles and things like that. I know that I like to use a program in here. So for some of you that don't know anything about a 90-degree angle or a 30-degree angle, here's a little activity with that. They can teach that. I'm sorry I messed that up. There you go.
So what grade are you in? Second.
10th grade?
First grade.
I was in 8th grade when I learned to program. I got my first computer when I was in 6th grade. What gets me excited is being able to fix people's problems.
You can express yourself. You can build things from an idea.
Computer science is the basis for a lot of the things that college students and professionals will do for the next 20 or 30 years.
I like programming because I like helping people. I get the opportunity to build something that's gonna make people's life easier.
I think it's the closest thing we have to a superpower. Getting started is the most important part.
I'm a beginner myself, and I want you to learn with me. Hi, my name's Lindsay. I majored in theater in college, but I also majored in computer science. And now I model, act, and write my own apps. Let's use code to join Anna and Elsa as they explore the magic and beauty of ice. You will create snowflakes and patterns as you ice skate and make a winter wonderland that you can then share with your friends. In the next hour, you're going to learn the basics of how to code. Traditional programming is usually in text, but we'll use Blockly, which uses visual blocks that you can drag and drop to write programs. This is how even university students learn the basics. Under the hood, you're still creating code. The concepts that you'll be learning are what computer programmers use every day and are the foundation to computer science. A program is a set of instructions that tells a computer what to do. Let's build a code for a program that will help Elsa create a simple line. We will use this later to create more complex patterns. Your screen is split into 3 main parts. On the left is the ice surface where you'll run your program. The instructions for each level are written right below the surface. This middle area is the toolbox, and each of these blocks is an action that Elsa and Anna can do. The white space on the right is called the workspace, and this is where we'll build our program. To move around the ice surface, you'll use the move forward block. Here, the move forward block says, move forward by 100 pixels. When we press run, what happens? Elsa moves forward a certain amount on the screen. 100 pixels, in fact. Pixels are basically very tiny squares on your computer screen. The other block we have in this puzzle says turn right by 90 degrees. And when we use this turn right block, that makes Elsa turn a certain amount. You can play around with how far you want Elsa to turn. The angle is measured from the path ahead of Elsa. So this is a 90-degree turn, and this is a 120-degree turn. And remember, you can change the number of pixels or degrees by clicking the arrows next to them.
All right, as I said earlier, this is going to teach some geometry using some of your math skills because that's a STEM skill. It says, help me create a single line. I say, okay. So let me see. The lines just go across there, so we can say, let's move forward by 100 pixels and see if it'll go. Let's run this. All right, I think we figured it out okay. That was easy. Now we have some idea what 100 pixels looks like on this code anyway. So this time Elsa's gotten to move forward. and then go down. And I think now another feature they have here is if you want to see the actual code, let me see, you can see that because it'll say show your code. I haven't written it yet. So also, if I want it to move forward faster, I can use the rabbit mode down here, or the slower, the turtle mode, or somewhere in between. So I think I'm going to have Elsa move forward 100 pixels, and then we're going to turn right. Now, I don't know what you know about angles, but when an angle is a right turn, that means it's a 90-degree turn. All right. And then I'm going to do move forward again by 100 pixels. Let's see what the code looks like. There's the actual code, move forward 100, turn right 90. All right. So that's the text code that a programmer would use. And that gives you, if you want to kind of take a look and see what that looks like, you'll be able to see. Well, let's go with our Blockly and see what we have. All right, we did pretty good. Now, this is going to get progressively more challenging, but we've got, look at all these activities we have, 20 of them. So it just keeps going and going. Now, this one says move forward by 100, turn right by 90. Then I think we got to move forward again. Turn right by 90. Move forward again. Turn right by 90. Move forward again. So let's see what we have here. There you go. All right. As I said, there are 20 activities to do. This one is not too hard, but let's see what you have to say.
Computers are really good at repeating actions. You can count 10 or 20 or 100, but a computer can count to a billion or a trillion. It won't get bored and it will only take a few seconds. Whether it's counting or drawing or anything, computers can repeat things hundreds or even billions of times. In programming, we call this a loop. A loop is how you repeat your code over and over again. For the next puzzle, your goal is to help Anna create a square with the repeat block. Any blocks of code you put inside the repeat block will be repeated in sequence as many times as you want. To draw a square, you could use the move forward and turn block 4 times. But the easier way is to tell the computer to move forward and turn by 90 degrees once, and then tell it to repeat this pair of actions 4 times. To do that, you need to put the move forward and turn block inside a repeat block. Remember, you can change the number in the repeat block to anything, and it will repeat what's inside the block that many times.
All right, for a lot of students, this is the first time that we start learning about how to use a loop. So I think she told us we're going to use 4 right here. So the last puzzle I did, I had to enter move forward and turn right 4 times a piece. This time we'll just use a repeat block. All right. So there you go. And as I said, as you go on, it gets more and more challenging. All right, we'll go a little faster this time. Let's see what this one says. Let's create 3 squares. All right. So let's go 3 right here. And we're going to turn right by, let's try 60. Let's run that. Uh-oh. No, I'm going to have to start over. All right, I did something wrong here. Let me see. I think 3 is still the right, but I put 60 down here. I think I might have to go with, let's try 90. Might be wrong. Let's see. Yeah, that's wrong. Reset. Okay. Let's go 120. Let's move a little faster now. So you can always do things over. I think we're on trays now.
Very nice.
As I said, it gives you an opportunity to learn about angles, pixels, and looping. So this program teaches a lot. And as I said, it gets harder and harder, and you have to think more with your brain as it gets more challenging. So that's one that we do. I'm going to see if I can find one that's a little bit more challenging for older kids, because as I said, you can learn at home. Educators, you can do elementary school, middle school programs, high school programs.
Got it.
See if I can find a middle school. Fundamentals. Let's see what this one is about. I don't know if it's that much harder. We'll try it. This is an entire course. We've got one I was thinking about from, it's code.org, but it's from Khan Academy. And it is a JavaScript tutorial. So you can do a little bit more challenging activity. I do it every year with my middle schoolers. Let's see if I can find that one. No. There's the Grinch. Khan Academy. Let's try, yeah, drawing with code. All right. Now this one, you actually have to use text and things like that. It's not Blockly. Anyway, let's try this and see if we can do it. All right.
Khan Academy team. So you're Pamela from the Khan Academy team. So you're here for Hour of Code, right? That's awesome. I can still remember my first hour of coding when I was a little kid, and now I'm on my 10,000th hour of coding, and it's still really, really fun. There are tons of ways to learn to code, and there's so many things you can do with code, like making games, like Pac-Man or Angry Birds or Minecraft. Or if you like science, you can use programming to visualize the way the universe works and help other people understand it better. If you like medicine, you can help doctors understand what's going inside the human body, because it's really crazy. You could make robots, like self-driving cars, you can analyze data, you can make websites like Khan Academy. There's so much you can do. Here on Khan Academy, you'll spend your hour of code learning to make computer-generated drawings. We can't cover that much in so little time, but we hope you're excited by your first taste of code and want to go deeper. Here's what you'll do in the next hour. First, you'll watch these interactive talk-throughs. They're kind of like videos where we write code and we talk while we're writing it, and you can see the result of the code on the right side. And you can pause it just like a video, but even better than a video, you can actually edit the code that we've written and see what happens when you change it. And then you can turn it back on when you want to keep going. Now remember, there's audio, so make sure you have speakers or headphones on when you're watching these. Next, you'll do a coding challenge. This is how you practice what you just learned and earn points for completing it, going through each of the steps until you get them done. Try to get through each challenge to the end, but if you don't and you're getting frustrated, don't worry. Just keep going to the next talk through. Finally, at the end, you'll do a more free-form creative project where there's no right answer, and the point is just to have fun while using what you've learned. And hey, if this takes you longer than an hour, that's totally okay with us. Here at Khan Academy, we believe that everybody should learn at their own pace. We'll always be here for you to keep learning, no matter how long it takes. Ready to get started? Let's have a coding party. Woo!
All right. So, this is some of the instruction that we get.
Let's begin programming by making a face with circles. To draw a circle, we need to use the ellipse command. So I'll type ellipse in this editor. After I write a command name in a program, I always follow it with parentheses and a semicolon. But I don't see an ellipse. The right side is still that boring white canvas. Well, there's no ellipse yet because I need to give more information about where to draw the ellipse and what size it should be. Since I am drawing a face, I want this ellipse to be smack in the center of the canvas and pretty big. I'll type 4 numbers in that'll make that happen, and we'll explore why they work. Ta-da! A face. Okay, so this first number, what does it control? I can change it by clicking on it and using the number scrubber that pops up. Watch, it's moving across the canvas. So this number controls how far the ellipse is from the left side of the canvas. What about the second number? If I change this, the ellipse moves up and down the canvas. Okay. On to the third number. Changing this makes the ellipse wider and thinner. All right, nice. Finally, the fourth. What else can we change? The height, making the ellipse taller and shorter, and squishy. Let's make it taller again. Okay, now you know what all of our
muted itself.
down the canvas. That's Y. And it also starts at 0 up here in the corner and goes to 400 down at the bottom. So that's X and Y. We call the third parameter width because it controls the width. And the fourth parameter we call height. Okay. So now we understand what our code is doing and why it's doing that. Let's write some more code. Well, we have a face. It needs a mouth so they can eat things. I'll make a mouth by typing a second ellipse underneath. I'm going to use the same X as the one before it because I want it to be in the center of the face, but I do want it lower down on the face. So I'll try 250 for the Y. For the size, I want it smaller than the face. Let me try 110. Ooh, okay, it's a little too small. I'm just gonna widen that up a bit. All right. Next, we need eyes because a face without eyes is pretty creepy. Let's start with the left eye. It should be closer to the left-hand side than the center. So I'll try 150. And it should also be closer to the top. So I'll try 150 for Y as well. And they should be small, perfect circles. So I'll try 30, 30. Okay. I don't see my eye yet. What's wrong? Ah, here's the issue. Oh no's guy, our error buddy, pops up and is telling me that something is wrong with the code. I am missing a semicolon. Where am I missing it? Line 5, the line of code that I just wrote. I forgot my semicolon. Classic mistake. I'll just add it back in. And here we go. We have our eye. Now, you will probably see oh no's a lot when you're getting started, because this is your first time writing code, and it takes time to get used to the syntax, making sure you're spelling things right and using the right parentheses and always putting that semicolon there. So don't worry if you see them a lot. You'll get used to it. All right, now finally, this is not a cyclops, so we need one more eye. Since our next eye is pretty similar to our left eye, I'm just going to copy this line of code and paste it, and then move the X, and there you go, beautiful. My face is finished, and I might be a little bit hungry too. Well, now you're going to try drawing some circles with code yourself.
All right. So when we use this program, probably many of you have noticed if you started with me that you were using Blockly language when that was pretty easy to do, but now we're using text-based and it gets a little bit more challenging, but it helps you understand what coding is all about. All right. So in this one, it says, in this challenge, you'll draw a snowman using the ellipse command. Now, we already were trained on how to do that. Start out by making a circle for the bottom of the snowman with an ellipse. All right, so let me see. If I remember right, I'm going to have to do an ellipse. Let me see. I've got to put 4 coordinates in there. So I think I'll just do 200, 300, 150, 150. Then it's real important when you do text-based programming, you're very strict. I'll have to put the, close my bracket, and then I have to put my semicolon in. All right, so hopefully, yep, there it is. I made it. All right, so that's that. Now, if I remember right, I'd probably needed to put, a snowman usually has at least 3 snowballs on top of each other. So this time, I'll put my ellipse. Let me see. Then I might do, that first one was 200. That was right to left, so I'm going to keep 200. All right, and then, but I'm going to make mine a little bit higher up. So I might make it, let me see, that first one was 300. I think I'll make it about 200. And then, let me see, I'll need to make it smaller. Let me see what I did. Let me make mine 100 and 100. And then I'll close my bracket, and then I'll put my semicolon. Let's see what we have here. Hey, man, old man Mo's getting it right. So you see my top of my snowman. Oh, I can see Kamari wants me to add the head to it now. So that snowman's got to have a head on it. So let's see what I can do. I'm going to do another ellipse, and I'm going to make it 200 because that keeps it in the middle. All right, and before I went, let me see, I went 300, 200, let's go 100. All right, and then let me see, that top head, I did 150, then I went 100, let's do 50. And then 50. All right, and then we'll close my bracket. Oh, dang, I think his head's floating in the air. I'm gonna have to get that straightened out. How do I make that head come on down some? Let me see. What if I made this 150? Whoop, too far down. All right, easy. All right, here we go. Let's go 75. No, that's not working. I'm not feeling that. All right. Oh, I like that. That dog will hunt. Look at that. Snowman got a little tiny head. But anyway, it looks like I'm doing okay. So I've made him a, says draw a second circle. All right. Let me see, using the ellipse command. Make sure your second circle is a little smaller. I think we did a good job there. All right, next step, let's see what we're supposed to do. All right, I think we're okay. Drawing more shapes. All right. So I think we're okay here. Let's see what this one is. Drawing more shapes with code. All right. Well, I think I did it. Let's see. The third ellipse for your head looks too small. Oh, I see what they're saying. My cranium's too small. All right, so let me do 70. And we'll go 70 here. Maybe they'll like that. Oh, I finished the challenge. All right. Congratulations, we did okay. Now, I don't know about the spin off. Drawing more shapes. Look at that.
Yippee!
Let's review what we already know, the ellipse function. I have 4 ellipses drawing a face. If I want to change something about this face, like make the mouth open wide, then I just need to find the right number and change it. Let's see, the mouth is the second ellipse and the width is the third parameter. So I'll just increase this. There we go. Nice and wide. Okay, so we understand ellipses. What else can we make? Well, we can make rectangles using the rect function. Another command that our programs here know how to obey. Here, I will draw a little neck for a face. I already know some good numbers for it. There we go. Just like ellipse, the rect function takes 4 parameters, and they're pretty similar. The first parameter is x, the second parameter is y, the third parameter is width, and the fourth parameter is height. But the parameters don't work quite the same way as they do for ellipses. Let me show you what I mean by turning this human face into a robot face, which means turning all these ellipses into rectangles. I will start with the top one and just type rect instead of ellipse, keeping the numbers the same. Whoa, okay, the rectangle is halfway down the page, even though it had the same parameters as the ellipse. Why is that? Well, the x and y parameters of the rect function actually control the upper left corner of the rectangle, not the center. So this rectangle now starts at what used to be the center of the face. So that means I need to do some adjusting of the x and y. I'll just decrease the x and then decrease the y. There we go. That's pretty good. Now I'll change the rest of these rectangles, change the rest of these into rectangles too. So this one like this, just move it over. So as you can see, you don't have to get numbers right on your first try. You can come up with some numbers, try them out, see if you like them, keep changing them till they look good. And if you have any graph paper handy, you can actually draw out your drawings on graph paper first, which I think is really handy for getting the right numbers. And then I'm just gonna move this over there. All right, looking good. So I'm liking this robot, but I don't like the fact that there's so many rectangles and I'm having a hard time remembering which of these rectangles draw which part of the face. To help me, I'm going to add something called a comment. A comment always starts with 2 slashes, and after it is a bit of text to help humans understand what the code does. So this draws the face. This draws the mouth, the left eye, right eye, and the neck. Okay, great. Now this code makes sense. Let me show you one more shape, a line, which I will use to draw a unibrow over the robot's eyes. I'll start by typing line. And once again, I need to type in 4 parameters. The first 2 parameters are the start point of the line. I'll start it where the left eye starts, 140, 150. Okay. Now you might think the next 2 parameters are the width and height, but actually lines don't have width and height. Lines have start points and end points. So the last 2 parameters will tell the program where the line should end. I want the unibrow to end where the right eye ends. So that would be 240 plus 30, 270. Okay? And I want this unibrow to be a straight line across. So I'll use the same y coordinate for the start and the end point. 150. Try it out. There we go. Looking good. But also looking a little bit mean. Like, I get uncomfortable around mean robots because I worry they'll, take over the world or whatever mean robots do. So we're just gonna get a little happier. There we go. Okay. Now let me show you one more thing about drawing shapes. Do you see how our function calls are ordered in the editor? The first one is rat, and the last one is.
All right, we're going to stop on that because of time restrictions. I want to recap some of the things that we've gone over. That if you go to code.org, it is free of charge. You can do it anytime, any time of the day. As long as your parents are all right with you logging on, you can go to code.org, and there are thousands of activities to do. Some of them easy, like that Angry Bird. Some of them are easy, like that Star Wars, and you use Blockly language. And then you can do more challenging things like this Khan Academy that we just did. I would like to show you a couple of the things that I have done with my kids in the last few weeks as we've had some summer STEM camps. All right, so I'm going to stop sharing here. All right, so there, I hope I am. All right, so I'm going to show you something we use. Many of you may or may not. Let me see if I can get my screen right. Have you worked with drones before? This drone right here is an inside program drone. We have several of them, and we teach drones at our school. Now, a lot of people, drones are just for remote control, and people take them out and they fly them around, and that's a wonderful activity. They use a controller like the one in this box here. All right, very common, and you can fly it around. But because I teach STEM, I teach programming. You can program this drone to fly by itself. You write the program on an app, and then you download the program on your drone, and the drone can do flips. It can go up and down. It can do anything you want it to do. And we also have a contest where we take our drones and we make them dance together, so they're all moving in the same direction at the same time. Also,
Wow.
I love this drone because it has a little camera in it. It has a little grabber, so we can make the drone pick things up. This is what the grabber looks like. And something I like, it has a little shooter. So you can go and it can actually, you can program it to shoot. All right. So there's lots of fun things to do with this drone. And we have used it to do a lot of things. And I thought I would show you the drone. And we have, as I said, at our school, lots of drones that we can use. We also have a big drone where we take movies, and we can go take it all the way out to the playground, and we can see what boys and girls are doing out there. And then we can bring it back, and we can make videos out of it. And that's a lot of fun to do with our big drone.
Wow.
But these are our classroom drones, and we have one drone for about every 2 children. So we have a bunch of these, but I thought that would be fun to show you what we have when it comes to drones. Also, I like to build things and engineer things. I gave every one of my students a bag like this, and I said, we're going to build something. So I put some pieces of wood in here, all that kind of stuff. I put this in there, another piece of wood. I put, oh yeah, I had this little cup in there. And then I just talked to them a little bit. Oh, I gave them a screwdriver, because when you work with this, and if you have a screwdriver, you must get a few screws. So I gave them that. I gave them some rubber bands. And when they finished, when I gave them all the instructions, I wanted them to learn how to work. And what they made was a catapult that can shoot. And this thing can shoot. And everybody got one to take home. And we made catapults. And then I had a contest where they had to bombard a cardboard castle. And they just shot it and shot it and shot it. So this is what we made with those. And so this is another STEM project that I like to do with my students each and every year. We also shoot rockets. I love shooting rockets. And we have 3 kinds of rockets we shoot. We have air rockets, and we made us an air cannon that would shoot the rocket way up in the air. We also made water rockets with water pressure. And then we also made solid fuel rockets, and they burn fuel and go up in the air and they come back with parachutes. So we do a rocket activity as well. We can show more of those, but what I wanted to do now is just let you know that you need to continue on watching these lessons and with Shiva Academy for the week. My part is coming to an end. I want to once again emphasize lots of things with STEM or STEAM activity to do science, technology, art, mathematics, engineering. Those are the wonderful things to do. And what you can do with coding is part of that. And you can go to code.org and learn all types of things about code. So with that, I'll say that I'm going to log off right now. And you all have a great day. My name is Mr. Mo. I'm a STEM teacher. And if you have any questions, let us know and we will be glad to answer those. All right. You guys have a great day and we will see you later.
See you later.
All right. Y'all guys did great.
Bye.
Bye-bye. Bye, Kamari. Bye, Ariane. Bye, Lucas.